So, welcome to this presentation on isometric to orthographic CDACC March 2025 building technology level 5. This is a question that was done, a CDACC question that was done in March 2025 by a class that is known as building technology level 5. And the question was appearing at number 15. So basically, this is the question. The question that came as an isometric question, which was supposed to be uh, done in orthographic. So this is the actual question, and we can see that same drawing here. Isometric projection, and this is the answer that you should have ended up with. So let's go down to it. Now, this is how the question appears, and I'd say the question number 11, number 15, but it is 12. The drawing provided is a part of a machine. Draw the first angle orthographic projection. So we also need to put at the back of our mind that this is a first angle projection. And we know that the difference between first angle and third angle is the orientation of the plan in relation to the front elevation. So in this case, we are going to draw the front elevation on top of the or above the plan, so that we would have it as first angle orthographic projection. Notice that most of the dimensions in the diagrams have been drawn from the horizontal plane. In this drawing, as we project the dimensions, look at this dimension. This dimension is coming from this horizontal plane, pushing from the horizontal plane. It is aligned to that, and it is aligned to this. So this one is from horizontal. This one is horizontal. This is horizontal. This is horizontal. This is horizontal. This is also horizontal dimension coming from that plane. Then we have this one also as a horizontal, this one also as horizontal dimensioning from horizontal planes. We also have those that have been done in vertical plane, like this one has been done in this vertical plane. This one is a vertical plane dimension. This one is also vertical dimensioning. This is vertical. This is vertical, and we can see that there are a few vertical dimensioning on this diagram, and most of the dimensions have been done in horizontal. So most of them are horizontal. You will realize that horizontal dimensioning, like in this case, sometimes they tend to be clumsy. They tend to be clumsy, and therefore, if you can do a vertical dimensioning, it would look better. It would look better. Let's have a look at one that has been done in vertical and see the difference between that one and this one. So here, in this one, we have probably only two horizontal dimensioning here. This is a horizontal dimensioning, this one two, and this one. So only three horizontal dimensions. But if you look at this figure and you look at the way the dimensioning has been done, the vertical dimension, they appear very nicely placed, and they do not actually interfere with the diagram. They seem to just stand out of the diagram so that they leave space for the diagram to be interpreted in its best way. If you look at the horizontal dimensions, the, the most instances of the horizontal dimensioning will fall inside the diagram. These are horizontal, it is inside the diagram. This is horizontal inside the diagram. This is horizontal dimensioning inside the diagram. All these others are external and they are vertical dimensions. So if you would use more of vertical dimensioning than horizontal dimensioning, you would you'd make sure your work is it would look better. It looks better, and we have seen uh, how that is. So to draw that diagram turn it into an orthographic, because that diagram is in isometric, we want to do it in orthographic. We will start with an orthographic projection we will start the orthographic projection by drawing a Cartesian plane using thin light lines called construction. So the first thing you do is do these crosshairs, this Cartesian plane. This Cartesian plane, this is +1, +2, and then -1 and -2. So we have four portions in which we can have our drawing placed. Um, in most cases, when we are doing a first angle, we shall always have our front elevation in this quarter, and then plan in this quarter, and elevation in this quarter. And if we were to do a third angle projection, the plan would be above in this quarter, and then the front elevation here and the end elevation here. So once we have done this using construction lines, lines that are thin, lines that are light, let it not be very visible, because this is not the end product. The end product is yet to come. This is just a construction line to assist you to get to the final product. And then we shall need to get a point here, to locate a point here, which is 20 to the x-axis, yes, 20 to the y-axis, and -20 to the x-axis. So place a point. So this point here is 20. The point is here, and it is 20 to the y-axis and -20 to the x-axis. So if this is the x-axis, it is negative. This side of the x-axis is positive. This is, this is positive y-axis, and this is negative. So it is positive y-axis and negative 20. 20 negative and 20 positive. That is this point over here. So you don't even need to draw these lines. You only need to get that point, because that's our beginning point where we're going to start our drawing. So given that this is the drawing that we want to put in place, and we have gotten our point, which is 20 negative and 20 positive. This plus sign here gives us the exact location, our Cartesian point, where we are going to place this corner. We are going to place this corner here, and because now we are doing orthographic drawing, we shall just be drawing orthogonally, meaning all our horizontal lines will be parallel to this, and all our vertical lines will be parallel to that. So, for example, this will be a horizontal line. The whole of this will be a horizontal line, and the whole of this, the height, will be a vertical line. So, we look at the measurements here, of which we have 80, and then 40, and then 40. So if we start here, we start with 80, and then 40, and then 80. Yeah, that would give us 200 millimeters. And then next, we go to that height, which will give us, the height here is 50, and therefore we measure 50, and that is going to give us, because we shall end up doing this rectangle here. We shall end up doing this rectangle, but uh, bearing in mind that our first point is this, which already is there. So we draw 80, 40, 480, and then 50, 80, 40, 80, and then we have our rectangle. So the rectangle is there. You can see that this is 80, this is 40, and this is 80, and then that is 50. So this yellow line here, this yellow line is what we have drawn. Um, uh, this depression here is around this area of 40, but you cannot see it because as you look at it in that direction, anything that is in a depression or anything that is elevated cannot be seen when it is facing you. So we have finished this part. Uh, next, Next, we indicate this line and this one, those two lines, which are at 80, then that line, then another 40, 40, and then that line, and we have that one. Next, we are now placing this top part. We are placing this top part. We have finished the lower part, which is 50 by 200. There's a 70 here. Measure that 70 from here up to here is 70, and then lift it. How much? This is 35. So lift it 35. That's another rectangle over there. So this is 35 by 70. This is 70 by 35. Then there's a rounded part, and this rounded part, uh, we can see that if you step at the center of this and it is 70, half of it will be 35, which is indicated here as 35. So step here, stretch your pair of compass there, and draw that one, and we shall have finished the next part. So let's move to the next part. These dimensions that I'm placing are supposed to come last, and dimensions should be lighter than the finished line. We should not have our dimension lines having the same intensity as the finished line. So let's not dimension our object this early. I'm only doing that so as to make us move together in unison. Next, we can now have the circular part here, which we saw as 25 millimeters. This hole here is 25. Just place your pair of compass at the center, stretch it 25, and you'll be able to draw that. Then there is that slope. There's that slope that comes from that part. You measure this 70. Once you measure the 70, and then you put a tangent to this circle, tangent to that circle, and we shall have gotten that right. Now next is now the projection. We want to do the end elevation. So the end elevation, this is now require us to project each and every line, each and every edge that we see. So this is the first one to be projected across. Remember, this is now across the Cartesian, because we said the front elevation will come on top, the plan will come below, below the front elevation, and the end elevation will come here. So we are now trying to plot the end elevation, and we are borrowing the height. We are borrowing all the heights. This is the first height we are borrowing with a projection line, and we're also borrowing this hole over here. We should have borrowed the center is borrowed. We should have also borrowed this part over here. Then we are borrowing this line there, and we are borrowing this height also there. So once we have borrowed this, then remember that we started our drawing 20 negative and 20 positive. So we shall continue with that distance here. We shall have 20 positive and 20 negative, where we are going to start our side. But what we are going to draw now is this front that looks like an N. Notice the yellow line. The yellow line is something that would appear like an N, and that is what we want to have here, like an N, and then we shall have the top there. So you can notice this N is 25 millimeters. So we already measured 20, and that's where we started this corner, and we did our 25. So do that 25, and then you lift it up 25, I think. Lift it 25 up to there, and we can see that this center line here is showing us the hole here. Then from here up to here, we had seen was 75. So just draw that 75 minus drop it down 25, and that way. And you notice that this is a cool N that has just landed there. And now the next thing is to draw this top part. We are going to see this as a rectangle, and this one as another standing rectangle. So we are going to have our rectangle here and another one right there. So looking at it, we have measured this one as 30. So measure 30 there, then lift it all the way up there. Then notice these dotted lines showing the hole here. Yeah, the hole right there, and then the lower part of the hole right there. Then if this is 30, this was 20. This is supposed to be 20. Therefore, after measuring 30, we measure another 20, and they all go up to the top right there. The both of them just reach the top like that, and we have finished this part and this part. So what is remaining is this notch over here, and the notch is 25 millimeters, and all the way down. And because it is hidden, it will remain in a dotted line. So the next thing is now to project our lines to this part. We are going to project all these lines downwards, like that is the first one. We are going to project this one, going to project the center line, going to project that one, going to project this one. We are going to project that, going to project that, and also that one. These lines will help us to borrow all the lengths. We shall have borrowed the length of 80, of 40, of 80, of 70, of 70, and so on. All these lengths will be borrowed downwards. And we need to do the same thing to this one. But because we want to combine these distances, we want to combine them with the ones that we are going to project down here. We need to have introduce a 45 degrees line from that Cartesian center. Introduce a 45 degrees line here, so that all the lines that are coming down will be deflected at that 45 degrees line, and they will be reflected at 90 degrees to now be able to effectively borrow the distance of 25, of 75, of 25, and these other distances. So you can now see the way the line of 45, that line is 45 degrees, and the first line here we are borrowing is this one, and then it's deflected at 90 degrees. Then the second line we are borrowing is this one over here, also deflected. The next one is this one, deflected, this one, deflected. We are also borrowing this one, deflected, and I think as we borrow this one, we are borrowing both this and also this one, because they are both of them at 25, and the last one is this one. So that now once we project these lines, we shall be able to see this part. We shall be able to see this part over there, like that. We shall see that top. So here we go, borrowing the vertical lines all the way, borrowing this one, borrowing that, borrowing this one, borrowing this one on that, and that one too. So all the lines are in place. So all we need to do is now to locate which point is this, which should be here. Yeah, and I think if we could just draw the outline is the whole of that like that, and then we can start cutting out the parts that we need and the parts that we don't need. So looking at it now, we can see that the outline is here like that. Then we have the hole here represented by this dotted line and represented by this other dotted line. Then we have this part represented by this part over here. And it also has some hole. You can see the dotted line here, dotted line coming from here and here. Then we also have this part which also has this slope, the slope right there like that. And so I think if now we can outline it after we have gotten this are now in construction lines. Let us try to make them bold to see now what we end up with. So here is our diagram. Looking at it now, we can be able to see that this is a hole over here, which is rounded, and this is another hole here, which is rectangular in nature. And basically, we are through with the diagram. Maybe I can add some boldness. some boldness, remove the whatever, so that all those construction lines that you use should not actually interfere with the diagram. They should be so discreet, yeah, very light at the background, such that as you finish the diagram, you do not have to erase any line. Yeah, you only need to make bold your lines for the finished object to be seen outstanding right there. So you can see that's a very beautiful diagram there, with this one being front elevation on top of the plan, and this one being end elevation. The dimensioning also matters. You need to put in as many dimensions as possible. That would help you to put together the thing. Don't miss any dimension. Here we already have these dimensions here. The dimensions of the height, we have the dimension of this part, and we have the dimension of the full. We can be able to get the dimension of this by subtracting this from that, and basically we can also be able to get the dimension of that to the center there, get that, and we have also indicated the radius of that. Therefore, there is no dimension that is missing. This is 40, and so on and so forth. So as far as the mentioning is concerned, just try to place in as many dimensions as possible to actually give us all the details. A missing dimension would mean that the diagram may not be easily reproduced. So that is the end of this presentation. Presentation was done by D.N. Kamau, a teacher at Sigalagala National Polytechnic, 2025. I hope you have really enjoyed this session, and you have gotten some concept out of it which may help you in your revision, and I wish you the best in your exams. Thank you very much, and don't forget to subscribe and to like. Thank you.